Hello everybody, today we're doing the right triangles and trigonometry, quiz 1. So then...
Copy to paint?
Yeah. No, put it at 100.
I did.
That's good. So then, okay, so then a monument in the shape of a right triangle sits on a rectangular pedestal that's 5 meters high by 11 meters long. The longest side of the triangle within Pythagorean theorem. So we only have these, and usually for Pythagorean theorem you need these two lines. So then, can you go to Pythagorean theorem? I just want to, can you put it like there maybe? So then, in Pythagorean theorem, we have a, so 11 squared, and put it back. And then we also have c. So that would mean, and c is 61 squared. So that would mean 61 squared. So we need to find b. So then, 11 times 11 is 121. So then 121, and then what's 61 times 61? So then that would be b squared equals, what was it? 3721. 3721. And then we minus that to each side, so then that would actually be really easy.
Can you just put in what's missing there?
What is it?
This looks like 121 times b squared.
Oh yes, plus.
Yeah.
So then we minus 121 to each side, so then that would be b squared equals 360. Divide side by square root each side.
Principal root of 365, right?
Yeah, just take the square root of both sides.
Okay, so you want me to take the principal root of this, yeah?
Yeah, but take the square root of it.
Well, square root gives you a plus and a minus. Principal root is only going to give you one positive, yeah?
What do you mean?
3600. I'm going to do square root button, right?
Yeah.
It tells me 60. Really, that in normal terminology, you could just call that the square root. But really, this is the principal root. Because if you really take the square root of 3600, there'd be plus 60 and minus 60. Plus and minus 60. That's the square root. There's two numbers that multiply by itself gives you 3600. Right? Plus and minus.
So take the principal root?
I did. So the positive one is the principal root. It's just the way that it's called. That's all.
So then,
I did the principal
answer is
root.
60.
Yeah, the answer is 60.
So what? But then the answer isn't actually 60. We still need to add 5. So
Yes.
that's 65.
Okay.
In our triangle shown below,
Hold on.
it's a 360-90 triangle. Triangle. We have the one that goes between here. We have the line that goes between here, which is 6, and that means you times it by times it by 2 square root of 3 to get from here to here.
Okay.
So then 2 square root of 3, and we need to find this line. So then 2 square root of 3, 4 square root of 3.
Okay. Good job.
Can you put it in paint? The
Tetrahedron.
super yacht designed by Jonathan Stwinge is a regular tetrahedron with edges 20
meters.
20 meters long. The distance r from one corner of the center of the base, shown in the picture below, is 11.5 meters. So r is 11.5 meters.
Yeah.
So then what's h? So then that's a 90, that's a 30, 60, 90 triangle. We know one of the lengths.
How did you figure out it's 30, 60, 90?
Because this is obviously a 90 angle.
Yeah.
This is very small, so it's probably 30.
Well, this is an assumption.
Well, okay, so then,
So
I don't think, actually that might not be a 90 angle.
there's a what between R and H? That is a 90 angle,
Oh, okay.
right? Because that's the
But no, it's going like that.
No, because it's in a three-dimensional drawing, right?
Oh, okay. So then,
There's a tricky one, but you can do it.
so oh, actually no, we know two of them. We know this one and we know R and that one.
How'd you know R?
We know R because it said that R is that. Well, and
There
then,
you go. Yeah, yeah.
Yeah, and then we know that
Yeah, that's good.
we know that this one is 20.
Just write a new triangle out.
Okay. Can you do it? Because then you can put like straight lines and then have it.
So you want me to draw a triangle just like that, yeah?
Yeah. Oh, okay. Yeah, just do that.
Oh, it's a triangle.
Oh, yeah, I forgot.
It's a triangle. Oh, it's the wrong way around.
You can just rotate it when you've put it there.
Okay.
You can also make the lines less thick. And then you need to actually
That's not it.
Oh, it's this one. These two.
There you go.
So, and then write the
You can write now.
So then we know that. Okay, so this is H. This is 20. And we know that this is 11.5.
Yes.
That's the Actually, I'm gonna just retry it. Okay, so then now we just do Pythagorean theorem. So then that would be. Can you put the formula here?
It's just
Okay.
a squared plus b squared equals c squared, right? The c squared is the hypotenuse,
Okay, yeah,
right?
fine. So then 11.5 squared plus h. Oh no, b squared. Should I just say h squared? No.
Either's fine.
Or do,
Let's do h.
yeah, h squared, and then equals 400. So then what's the square root of 11.5?
11.5 squared, yeah?
Yeah. So then that'll be 132.25 2.25 plus h squared. H squared equals 400. So minus 400 by 132.25. So then that would be h squared equals, what was it? 267.75. 267.75. So then, is that the answer? And then we need to round it to nearest 10, so that would be 267.8.
No.
Oh,
How's that the answer?
because we found, take square root of both sides.
So you want the principal root of 260?
Yes, whatever.
No, it's not whatever. It's the principal root.
But no, well, why haven't I been saying principal root? Well, then why was I saying take square
Because
root?
up until now, I've been doing algebra 1, where you really do need the square root of the plus and minus.
But then the principal root isn't the principal. You did the principal root, and it was the exact same thing as doing the square root last time.
No, I wasn't.
Well, then
So it's 16 point what?
16.4.
16.4, yeah?
Yes. The right triangle is shown. 30, right, put the formulas. Okay, so in the formulas, it's 30, 60, 90 triangle, and we know we need to find this one, and we have that one. So it's 6 square root of 2, 6 square root of 6.
Yeah.
An airplane takes off, levels off, and lands accordingly to the diagram shown below. All measurements. Daddy, why wouldn't it go more like this?
It would in reality, but they're just trying to do a model for it.
Why
That's
didn't
the flight plan, is that one. It says reach a certain altitude. Once you're there, just coast, and then once you're ready to come down, then come down.
then why don't they reach the altitude slower or something?
In reality, they would. They're just oversimplifying it so that it fits the math problem.
Okay. So then what is the horizontal distance from the plane's starting position to its finishing position? So then basically we need to find we just need to do Pythagorean theorem in this triangle and this triangle, and then we just need to do Pythagorean theorem on these two triangles.
Yeah.
So then, so that would be 3 squared. 3. I'm just gonna write 9. 9 plus y squared equals 49. Divide that by 9. That would be y squared equals 40. And then this is square root of 40. Oh, it's it's, I don't know.
Just write the square root of 40 for now.
Well, it says to round it to the nearest tenth, so I'll just
Alright.
okay. I'll just write that and then round it to the nearest tenth. Okay,
6.3.
6.3. So then equals 6.3. Well, actually, I'll just write. Okay, 6.3. 6.3. 5 squared, 25. X squared equals 3 squared, which is 9. Minus each side by 25.
You done a mistake then. Well, you're about to discover it anyway, so carry on. Sorry.
Did I like get these wrong order?
Yeah.
Okay. So then
Because where does the hypotenuse?
it's that long.
Yeah.
So 9, 25. So minus each side by 9. X squared equals 16. Right. Squared 4. So equals 4. 4 plus 3, 7. 4 plus 3, 7. 13.3. Why would they be driving on plane 13.3 meters? Kilometers.
Not sure.
Mm.
Good job.
Okay.